Welcome back to the final video, I hope, in this series. We're looking again at nested loops, and we want to give some programming examples to show you how to go about coding situations that require nested loops. Here's the example that we saw before, and we said this is the two-dimensional problem. I have to produce outputs going this way, so I must move horizontally and then vertically. But we said basically the root problem is just to produce this line of output and to repeat it. So let's take a look at some code that will do that. So let's take a look. What we see written here, this loop, is really the code that produces one line. So what do we have to do? We basically have to do what we said here. Repeat the root problem 5 times. So here is the root problem. So we would need to repeat it 5 times. We do that by creating an outer loop that repeats 5 times. That's the outer loop. Now we're going to, just for simplicity, we're going to indent the inner loop. And so we have an outer loop that takes us, that completes one row and moves down. So when we compile this and run it, what do we have? When we run it, we have what? We have the output that we desired to have. Reiterate. In this case, the pattern is clear. Do the same thing 5 times. Let's move to another example and see what's involved there. In this case, we want to produce two-dimensional output again. What's different? The first line is 1, 2, 3, 4, 5. The second doesn't start at 1, it starts at 2. The third line doesn't start at 1, it starts at 3, and so forth. So we basically must repeat something 5 times. So again, we need an outer loop that goes 5 times. The inner loop must generate what sequence though? The first time is the sequence 1 to 5. On the second line, on line 2, the sequence is 2 to 5. On line 75, the first number will be 75. So let's take a look at the kind of loop we need to accomplish this. And here we have the whole solution. We have one loop that identifies which row you're on. Oh, it's not quite right. And this other loop does what? It produces numbers 1 through 5. Now this looks like the solution for the previous one, because this time we said we don't want to start at the same point every time. We do count up to 5 each time, but we don't start at 1. Where do we start? First time through, we start at 1. Second time through, which row are we on? 2. We start at 2. Third row, where do we start? At 3. So it sounds like a variable goes here and not a constant. What's the appropriate variable? The variable that tells you what row you're on. So we're going to say row. Alright? So let's see if that's going to work. Okay, are we getting what we want? I believe we have. Okay. What's the moral of the story? You must see what relationship there is between what's produced on each line in case it is not the same every time. We must identify what is changing and adjust the inner loop. Let's do one more. Let's suppose we wanted to produce this loop. What are we doing? We're actually counting from 5 backwards. Then we're counting from 4 backwards. Then we're counting from 3 backwards. Okay. So, how do we solve that one? Okay. So again, we must keep track of which row we're on. And what do we have to do here? Notice that if we put this in, we will get the whole sequence every time. So let's notice a few things. One is that we're counting backwards. So whatever we do, we must be counting backwards. Agree? What's the next thing? As we count backwards, we are always counting down to and including 1. Okay? So now we've adjusted the counting of the inner loop, so when we do the row, we're going down. But what remains is, what is the starting point? First time out, the starting point is 5, and then it's a 4, then it's a 3. What's a good way of looking at this? Well, there's a lot of ways. How about saying, what's the relationship between 5 and the row? Okay? When row is 1, the first number is 5. When row is 2, the first number is when row is 2, the first number is 4. And if you fish around in your head a little bit, you will say, well, the starting point is a function of what the row is. And it really is 6 minus the row, if I want to give it away to you. Okay? So when row is 1, it's a 5. When row is 3, it's 6 minus 3 is a 3. So I think this will do the trick for us. Let's take a look. And what do we have? Do we have what we want? I think we do. 5, 4, all the way down to 1. All right. Now the last example is a little different because there's nothing magical about for loops. I can nest any kind of loop inside of another loop. Now let's look at another problem that we have. And I need you to visualize. The problem is that I have 3 students. Again, the number doesn't have to be 3. And I have scores for every student. The scores are terminated by a sentinel, -1. And what am I doing? I'm reading the scores for the first student, calculating the average. Reading the scores for the second student, in this case there are no scores, and calculating the average. Reading the scores for the third, calculating the average. Okay? So here's a question. What is the root problem? The root problem is, forget about doing things 3 times. If I had to just calculate the scores, calculate the average for one student, given the way the input is designed, can I do that? If you recall, we have solved this problem before, really by using a while loop. And so let's solve this problem. Let's go in here and solve it. All right. So let's solve the inner one, the root problem. This is getting a little more complicated than you think. Well, let's just do the reading. We don't need a for loop, we need a while loop instead. So how does the while loop work? It's a read, check, use. So first thing we're going to do is read in a score. We're going to check it. What checking? The score cannot be the sentinel. So we're going to say, while score is not equal to the sentinel. Now we're going to use it. What does use it mean? Well, it means we're going to add it to the sum. Which means we got to get up here and make sure that before we get started, that we're going to say sum is 0. And again, the pattern is read, check, use, which must be followed by read again. All right? And when we're done with this, we're going to, for right now, we're going to simply output the sum, just so we can see how things are going. That's all we're going to do. We're just going to run it. And we're going to enter some data. Say -1. Sum is 0. That's correct. Run it again. Say 440, 50, and -1. So it looks like we're computing the sum. So we can go back in and finish solving the base problem. What's the basic problem? The root problem. The root problem is we want to calculate the average. Well, what's the average? Well, the formula for average is average is equal to the sum divided by how many values you had. We don't have a number of values yet. So it sounds like part of what we need to do is count. So we need a counter. So when we read a value, we're going to count the value. And add the value. So then when we get done, we have a count. So we can do that. Let's do one quick step. Let's do it again. So we're going to give it 40, 50, 80, and -1. The sum should be 170. Oh, we didn't do the average though. It says sum is this, average is that. And that looks kind of reasonable. Alright, now let's do one last thing. I'm going to run it this time. And suppose there are no values at all. What happens? It says floating exception. What's really causing this? What's causing it is you're trying to divide by 0. So let's get back and fix the code so we can avoid that. Okay, so how do we avoid it? We got to check count first. If count is greater than 0, then I can do this. Else what? Otherwise, I'm going to set the average to 0. Okay, and that is the right thing to do. Let's try to run it again and see what happens. Minus 1, it comes out saying sum is 0, average is 0. Now, what have we here? It looks like we have solved the base or the root problem. So now we need to do what? We need to go ahead and repeat the solution a certain number of times. So this problem says the first input is the number of students. And then we want to repeat that many times. Or do we repeat all of this? This is the outer loop. Alright. Now I think with this you can see for yourself that this is probably going to work. So compile it, run it. I want to say there are 2 students. The first one is 40, 50, whatever. Oh, I forgot the minus 1. Then the second one is going to just be minus 1. So it looks like we're producing the right answer. And with that, I think we've kind of hit the end of this. Alright? Now, for your edification, all of these programs that you see called Nest Loop are all placed in the public repository for your viewing.